Hello everyone, good evening. I hope all of you are doing well. So let us start then. Yesterday we covered the topic how to make structures, right? And we practiced some of the structures. So today we'll continue the applications of that, like how you can find hybridization and the bond angle and remaining things from these structures, right? So yesterday on the last point we were discussing how to find a coordinate bond in your structure, right? If you have structure, how do you know is it a coordinate bond or not? So I told yesterday, so I'm writing those things again. First of all, what is coordinate bond? A coordinate bond is a bond in which both the shared electrons will be given by one of the atom, and other electrons will just other atom will just use these electrons to make the bond. Okay, in normal covalent bond, both, like I will say, one electron given by one atom, other electron given by other atom, right? But in the coordinate bond, both electrons will be given by one atom and the other atom is giving nothing, just sharing them and making the bond, right? Okay. So how we can find there is a coordinate bond in the given structure? If you have the structure, right, first of all you need structure, then how do you know in this you have a coordinate bond or not, right? So how we can check that? First I told how to check. Nitrogen normally make 3 bonds. It can make maximum 4 bonds, but normally in the compound it makes 3 bonds, right? Because it's you can say its valency is 3, it have 5 valence electrons, it want to make 3 bonds, right? But maximum covalency of nitrogen how much? 4. So whenever you see a nitrogen atom is making 4 bonds in the given structures, that means definitely one of the bond is a coordinate bond, right? So if I write here, if nitrogen, okay, neutral nitrogen, if nitrogen form 4 bonds, right? If nitrogen form 4 bond, one bond will be a coordinate bond. One bond will be a dative bond, you can say, okay, and you can say coordinate bond. Both are same things. Don't confuse yourself. Dative bond or coordinate bond, fine. The second point, if I say, I'm saying here, if now if we talk about the oxygen, okay, normally oxygen make how many bonds? 2 bonds, right? Normally a neutral oxygen makes 2 bonds. Whenever you see oxygen making 3 bonds, definitely the third bond is a coordinate bond again, okay? So if oxygen form 3 bonds, if oxygen form 3 bonds, definitely one bond will be a coordinate bond. One bond will be a coordinate or dative bond, right? Clear, bacha? And if by chance you see, if oxygen, neutral oxygen, right? I'm not saying a positive charge or negative charge, right? I'm saying neutral oxygen. If oxygen is forming a single bond, forming one bond, just one I am saying, if oxygen is forming one bond, that will be a coordinate bond. I'll give you some examples. That will be a coordinate bond, right? Remember, nitrogen as well as oxygen both belongs to second period, right? These belongs to second period and their maximum covalency can be 4 only. They can never expand their octet, right? They can't have more than 8 electrons. I told yesterday, okay? So these 3 points you keep in mind. Most of your questions will be solved of the type of like dative bond or coordinate bond, right? If I'm giving one example, right? I'm making one structure here and then you have to think, is it having a coordinate bond or not? So I'm making ozone here, right? This is ozone. This is ozone. Clear, bacha? This is ozone. So we don't know this is having a coordinate bond or not, but we can check very easily. If you go by the rules, you will make the structure, it's fine. But definitely the rules will not tell you that this is a coordinate bond or which type of bond. Now you have the structure using the rules, right? So any rules you follow, you have made the structure. You made the structure, right? So how to check this is having a coordinate bond? Fine. I told the second point, you see, if oxygen anywhere in a molecule make 3 bonds, so definitely one of the bond is a coordinate bond, right? So here you can say, yes beta, here you can say oxygen is making how many bonds? 1, 2, 3. The center oxygen is making 3 bonds. So definitely one of the bond is a coordinate bond. And the third rule I am saying here, by chance you forgot about, right? Yes beta, hello. So the next one I am talking about, this oxygen, right? This oxygen you are having here, this oxygen is having just a single bond. This oxygen is having just a single bond. So by using the second rule, or you can use third rule, any of these rule is telling you that your compound is having a coordinate bond. Which bond is a coordinate bond? If I say, right? Definitely, whenever oxygen, a neutral oxygen make a single bond, it is a coordinate bond. Right? Yesterday I explained this part. You can think about it how. So normally I am taking here 2 oxygens, right? 2 oxygen are there, and both oxygen want to make what? 2 bonds. They will make double bond, like O2 you can say, right? After making this better, you see this oxygen is having 2 lone pair right here, and this also have 2 lone pair. Clear? But now if you check, third oxygen also present definitely. If I am saying O3 molecule, definitely there is one more O, na? So if you put this O here, how it can make a bond here? Because if you make here simple covalent bond, single bond, double bond, it will, you can say it will expand the octet of oxygen, right? If you make here this double bond, normal double bond, it will expand the octet of oxygen, right? Which is not possible. That's why you will see oxygen will do one thing. Oxygen will say, okay, we'll do one thing. I will keep both these electrons here to make which bond? To make a coordinate bond. So both the electrons are coming from this oxygen, and this oxygen is not giving any of the electron. It was having 6 valence electrons, 6 are present as it is, and both electrons are given by the center oxygen to make which bond? To make a coordinate bond. If you go conceptually, we think this way. Otherwise, if you have the structure, easily you can tell this is having a coordinate bond or not, right? Similarly, if I say, bache, for example, if you see, I am taking the HNC. This is HNC. This is your HNC, fine. Can you tell me this is having a coordinate bond or not? Yes, bacha. Is it having a dative or coordinate bond? Yes or no? Tell me. Can we check this? We have the structure, we made it by our rules, okay, no issue. In this structure, are we having any coordinate bond? And how we can check this? Because nowadays, they don't show arrow for the coordinate bond. They will show just simple bond. Okay, yes, bacha. Yes. How you can say that? By which rule? By which point you can say that? You see with the first point, whenever nitrogen make how many bonds? 4 bonds. Whenever nitrogen make 4 bonds, it will have a coordinate bond, right? Okay, so I can show one of these bonds, which are which bond? One of these bond is a coordinate bond. Whenever nitrogen making 4 bond, it will be a coordinate bond. Fine, bacha, right? Okay, so this is the way. Now I am asking you a simple question. I am giving you some examples. Please try and tell which of these is having a coordinate bond or not. Fine, bache. So check with it. Which one? Or I am saying which among the following have coordinate bond? Which among the following have dative, or you can say coordinate bond? Clear, bacha? Done? So if I say here, one of the thing I am writing here, imagine we are having HCN. right? And I am taking one of the example here. You can say you are having N2, you are having N2 here, right? Or if third I am saying, imagine we are having O3 here, right? N2 we are writing. Just simple I am saying N2. This simply we are having N2, and one more I can take here. One more I am taking here, like you can say, okay, we are having N2O5. These four are the molecules, and we have to check which of these. I'm not saying only one is the answer. Maybe out of these four molecules, two can have coordinate bond. Maybe all have coordinate bond. You have to check that away. Okay, right? Okay, bacha. So, okay, you're saying first, check beta, check carefully. Check carefully. Gayatri is present. Yes, loyal man. First, you are saying beta, check carefully. Okay, let me give you the structures, right? I'm giving you structures, then you can try, right? Okay, so we are having HCN, N2O, okay, N2 and N25, right? Let us see. I'm giving you structure. First one, HCN, right? If you make with HCN, we are having hydrogen here, carbon here, nitrogen here, right? We know carbon make how many bonds? Carbon to make one bond, right? Sorry, carbon make total how many bonds? 4 bonds, right? Normally, in general, carbon make 4 bonds. Clear, bacha? Now, nitrogen normally make how many bonds? 3 bonds. So, nitrogen is making here 3 bonds. Carbon total 4 bonds, and hydrogen making 1 bond. Simple structure. So, in this, you see, beta, nitrogen is making only 3 bonds. By any of the rule, can you check? We are having a coordinate bond? No. Carbon normal 4 bonds, nitrogen normally 3 bonds, and hydrogen how many? 1. Nothing special here. Nitrogen is making only 3 bonds. None of the bond is a coordinate, all are simple covalent bonds, right? The next one I'm taking here, it was N2O. If I show like this one, N2O, right? You're having N2O here. Now you see, I'm giving a structure. You can make this way. It's N2 like N2, and it was having a lone pair. That lone pair it is giving as a coordinate bond, right? Or I am not showing the arrow part. I'm just showing it is the N2. By looking at it, can you tell me, is it having a coordinate bond? Yes, here nitrogen is making 4 bonds, right? Here nitrogen is making 4 bonds. So you can see 1, 2, 3 and 1. So the center nitrogen making 4 bonds. Definitely one is a coordinate bond here, right? So this is the right answer. Now third one, if I talk about, just simple, I think N2 I gave, right? Simply you are having which one? N2. None of the thing is telling me it is having a coordinate bond, right? And the fourth point, if I say, bacha, the fourth point, I think I gave N2O5. I am giving a structure, then you think about it, right? I am giving a structure here, right? This is your N2O5. This is N2O5, right? Can you check, beta, in N2O5 do we have a coordinate bond? How we can tell? Yes, right answer. Yes, bacha. How many are there? If you check carefully, in this nitrogen is making 4 bonds. You can find there is a coordinate bond by checking, because nitrogen having how many bonds? 1, 2, 3, 4. Nitrogen making 4 bonds. So it is a coordinate. It's a definitely coordinate. And the third point, oxygen is making a single bond. Definitely, whenever oxygen make a single bond, which bond? It is a coordinate bond, right? So this one is a coordinate bond here. This is also a coordinate bond here. And here is also coordinate, right? So out of these, second and fourth are having the coordinate bond, right? Clear? Now let us see one or two more example. Imagine if I am giving you beta here, it's NO2 plus. It's NO2 plus. Be careful. In NO2 plus, check beta, please. in NO2 plus, do we have any coordinate bond? In NO2 plus, do we have any coordinate bond, right? If you make it like NO2 plus, N is plus here, N is plus, N plus have 4 valence electrons, the 2 bond here and 2 bond here, right? This is NO2 plus, be careful. So here N is making 4 bonds, but be careful, here N is not a neutral nitrogen, it's a positive charge nitrogen. So here I will not say it is having a coordinate bond. In NO2 plus, N plus is there and it have only 4 valence electrons, so it will make normally 4 bond. N plus is like carbon only. N plus is like carbon only, so definitely here there is no coordinate bond, normal bonds, right? These are the very common examples, okay, which repeat again. Let us give you one or two more question. We are having here CO2, right? CO2. Can you predict in CO2 do we have? CO2 this one better. Okay, we have seen the rules how to make the structure, right? CO2 I'm telling you. Oxygen make double bond, oxygen make double bond. So tell me now, is there any coordinate bond? No. None of the point is telling me it is having a coordinate bond. Oxygen having 2 bonds, both oxygen having 2 bonds, nothing special beta here. So definitely it is not having any coordinate bond, right? Now, this time think about it. I am giving you CO, right? The structure of CO is this one. This is CO beta. This is CO. This is CO, right? In CO, please use the 3 points and tell me, is it having a coordinate bond or not? Is it having a coordinate bond or not? CO I'm talking about. CO is having a coordinate bond, yes or no? Tell me, bacha. CO. You can see clearly, oxygen is making 3 bonds, right? And I told, whenever oxygen makes 3 bonds, it is having a coordinate bond. Yes, bacha? Okay, great. So definitely there is a coordinate bond, and I can say simply how we made it. C and O, right? So carbon normally want to make 4 bonds, but oxygen want to make how many bonds? 2 bonds. After making 2 bonds, right? Oxygen is saying, okay, I am so happy, I don't want to make more bonds. But carbon saying, array, I am not happy, but my octet is not complete. But you see, now the oxygen can't make simple bond. If oxygen will make simple bond, covalent bond, then its covalency will, its octet will expand. So what oxygen do? Oxygen will help carbon and say that, okay, I am using one of my lone pair and I will put it as a coordinate bond. In that way, oxygen also have 8 valence electrons and carbon also have 8 electrons. Both are happy now, right? And simply don't use that much mind, you know. Oxygen making 3 bonds, so one bond is which bond? Coordinate bond, that's it. Okay, this way easily you can find. Okay, one last I am asking here, then we'll come to the next application of structures, right? I am having NH4 plus. In NH4 plus, can you tell me, are we having coordinate bond? I am showing a structure of NH4 plus. This is NH4, right? Here we have NH4 and plus is on, remember, plus is on hydrogen. NH4 plus, H is less electronegative, so this H was on hydrogen, right? H plus. So tell me now, in this case, do we have a coordinate bond? Yes, we have here a coordinate bond, right? You can think this way. Ammonia that we are having here, it is NH3, right? It is NH3 here. H plus was present, right? In this case, H plus have no electrons to make bond. It is having 0 electrons, right? But nitrogen here was having a lone pair. Nitrogen here was having a lone pair, right? So the nitrogen will use these 2 electrons to make which bond? To make a coordinate bond, right? So it is having a coordinate bond, right? So these are some of the important examples where they can ask these structures are having coordinate bond or not. There are many structures definitely we will see in our offline classes. Okay, bacha? Done? Done to here? Okay, so now next we will see the formal charge. If you have the structure, of the compound, using the structure you can easily find the formal charge, right bacha? Let us see the second application of structures. Okay, the second we are discussing here formal charge. Right? Okay, bacha. If we have a structure, then on some particular atom they can ask the formal charge, right? How do we define the formal charge? Yes, bacha. Okay, so first thing here, for the atom for which you are finding the formal charge, you take its valence electrons, right? First thing is you have to take its valence electrons, number of valence electrons, right? The first thing is you have to take number of valence electrons minus beta here, valence electrons minus, you will see the next thing is number of unshared electrons. The next thing you will see, we have to check here, it is having how many unshared electrons. Unshared electrons means which are not participating in the bond formation or which are present as a lone pair, we can say outside the bond pair, right? And the next thing is half here 1/2, and here number of bonded, you can say number of bonded or you can say shared electrons, number of bonded or shared electrons, right? This is the formula, very simple formula, bacha, right? So how we can find the formula charge? Let us see. The most common example in the NEET exam or in the NCERT, if you check, bache, I am having ozone. Just now we have seen the structure of ozone. This is ozone, right? This is ozone. If I show electrons lone pair also, beta, this oxygen have 2 lone pairs. These are all questions you can do if you know the structure, right? This is the structure of ozone. Now they can ask, like I'm telling you, I'm asking you here, it is oxygen number 1, it is oxygen number 2, it is oxygen number 3. So I'm asking, tell me bacha, what is the formal charge on oxygen number 1, right? So our first task is to find the formal charge on oxygen number 1. Okay, can you tell me what's coming? Okay, yes, bache, what's coming? So, okay, I'm telling you the first one. In this case, valence electrons, how much, bacha? Oxygen have 6 valence electrons, right? 16 group element, minus of unshared. It have how many? 1, 2, 3, 4. 4 unshared electrons minus 1/2. It have how many shared? If you check, beta, 3 bonds. 3 bond means 6 shared electrons, right? So here we have 6 shared electrons because it have 3 bonds. 3 bond means 6. Okay, so here we have to see we are having 3 bonds. 3 bonds means every bond is made up of 2 electrons, so you can say 6 electrons, right? So here we can see which 6 minus 4, and here you can see this part. What's coming from here? It's coming 3, and what's coming from here? It is giving us what? 6 beta here, 6 valence electrons, here 4 unshared electrons, and here 2, 3. So coming what? Minus 7 and 6 here, right? Coming how much? Minus 1. Clear, bacha? The next one we can go. The formal charge on second oxygen. Tell me, bacha, what is the formal charge on second oxygen, right? This one. So we are having here how much? 6 valence electrons, same thing here. Minus beta, it is having how many unshared? 2 unshared here, and here we have half. And wait, we were finding for this one. Sorry. We were finding for this one. Sorry, wait, small mistake here. I took this one. I was finding for first, right? I was finding for F charge of first one, right? First one having how many bonds only? 2 bonds, right? So here 2 bonds are there. So how many are there? 4. Okay, I found actually for the second one. but here I am writing first one, so be careful. 6 valence electrons minus 4 are beta what? Unshared here. And how many shared for this one? This is having 2 bonds, right? 2 bonds means how many shared? 4 shared, right? So from here if you see 2 is coming, so for this one, what is coming beta? 0, right? Actually I found for second oxygen. Clear, right? Now come to this one. Next beta, this one. 6 here, and here we have 6 valence electrons minus how many? 2 unshared, right? Here we have 2 unshared, clear? And now the next one is, it is having 3 bonds. 1, 2, 3. 3 bonds are there. So 3 means beta how many? 6 shared, right? 6 shared here. So what's coming here? So 6 minus 2, and what here? 3. So 6 minus 2 here, and how much? 3 here. So what's coming, bacha? It's coming 1. It's coming 1, right? Okay. Next one, if I talk about the formal charge, bache, for which one? The formal charge for third one, right? The formal charge for third one, clear? This is having 6 valence electrons, bacha. 6 here are the valence electrons, and you see it is having how many unshared? 6 here unshared, and minus of half, bacha. It is having 1 bond. 1 bond means 2 shared electrons, right? So here how much? 2 shared. So what's coming? It's coming minus 1. It's coming minus 1, right? So for first one 0, for second one 1, and for third one minus 1, right, bacha? Clear? Okay. Yes, bacha, very good, beta. Loyal man. Yes, bacha. What's your name, bache? What's your real name? What's your real name, bacha? Okay, the next one I'm going to talk about, there is H2SO4. Okay. Fine, for this one now. We are having sulfuric acid here, H2SO4. So it have 2 structures. Like first one, the more accurate one I am talking about here. This one is the more authentic, the more real structure, H2SO4. Clear? Now here I am saying we have find the formal charge for the sulfur. Look at this and find the formal charge for sulfur here, right? Okay. Dilip Royal. Okay, tell me now. So for the sulfur, find the formal charge now this time. For the sulfur, find the formal charge. Make it fast. Yes, beta. Okay. What's coming? So here you can see, bacha, sulfur is having how many? Sulfur is having 6 valence electrons, bacha, you see. Sulfur is having 6 valence electrons minus, bacha, how much here? Is it having any unshared electrons? No, this is not having any unshared electrons, so 0 unshared electron, right, bacha? And minus 1 by 2. How many are the bonds? 6 bonds. 6 bonds means 12 shared electrons for this sulfur, right? Yes, bacha. So 12 will come here. So from here if you find 6 minus 0, and here also 6 coming. So overall how much coming? 0, right? Very good. 0 is coming. Fine, bacha. Okay. So very easy. The formula you know very well. Easily you can give the answer. Fine, bacha. Right? Okay. Now next one. Now if you see, there is one more structure for sulfuric acid. If you have seen the Lewis structures and all these things, before this structure, before the D pi P pi concept, one more structure was given, right? I am writing that structure here. So here this is the structure. It's HOH here, and I am showing sulfur. I am showing this as a coordinate bond. Okay, I am not talking about D pi P pi concept. I am just showing a coordinate bond between sulfur and oxygen instead of showing double bond, right? They will give you structure. Okay, so I am giving structure. I am asking in this structure sulfur formal charge. I am asking, right? Tell me the formal charge for this sulfur, right? Tell me the formal charge of this sulfur. Yes, bacha. Yes, but tell me what's coming. This is a coordinate bond, right? This is a coordinate bond. there is no need to show, but in this structure, in this concept, we are saying there is a coordinate bond. Definitely that one is authentic one, the real structure. Okay, it was given before it. If I see both structure are there in NCERT, but second one, that one already I gave, that is authentic one. Why? We will discuss about it. So tell me, here sulfur beta, how many valence electrons? 6 valence electron, right? Minus how many unshared? 0 unshared here, and 1 by 2, how many shared? It is having how many bonds? 1, 2, 3, 4. 4 bonds beta means 8 electrons, right? So 6 minus 0, 2. So what's coming here? 2 is coming, right? In this structure, the formal charge is coming on sulfur like 2. In the previous structure was coming 0. So if you ask, sir, which one is more authentic? So I will say first structure was more authentic, because in that structure the sulfur was having lower formal charge. Those structures are considered to be more stable, where the atom will get lesser formal charge. Fine, bache? Done? Okay, so this way they can give some structures and they can ask the formal charge. So very, very easy, nothing tough here. Okay, bache? I hope we are clear about it. Okay, one last question I am giving. Please find for this one. Here we have, I am taking this one. We are having H3PO4. So find beta 4 phosphorus. I am asking, find formal charge for phosphorus. Apply simple formula and find formal charge for phosphorus, right? Just the formula revision. Tell me, what's coming? Formal charge for phosphorus. Hey, bache, what's coming? Here you see, we are having how many, bacha? We are having 5 valence electrons. Phosphorus belongs to 15th group. 5 valence electrons minus, bache, how many unshared? There are no unshared electrons. Fine. And minus of half. And how many which are shared here? It is having 1, 2, 3, 4, 5. 5 bonds means 10 electrons, right? It is having 10 electrons. So 5 minus 0 minus here 10. So if you cancel out, what's coming, beta? 0, right? Here 0 coming. Yes, beta, 0 coming. Good, right answer. Okay, fine. So this is it. Like formal charge, you can solve the question of formal charge by the formula. Simple concept, right? The next one I'm coming to is the bond order, right? The next thing which is bond order. It also depends on structures. All of these are the application of structure. If you know structure, then only you can tell these answers, right? Okay, bacha, great. So the next one is your bond order. Clear, bacha? So what about the bond order? What is it? Bond order is number of bonds between two atoms, right? So if they ask in these two atoms how many bonds are present, so it is the number of bonds between two given atoms, right? So very easy concept, very, very easy, but it becomes a little bit good when the structure, when the given structure have resonance, right? That we have to understand mainly. Okay, like simply if I give example, very, very simple. If you know, like hydrogen, I'm talking about H2. So H2 beta have simple HS single bond, right? Whereas O2 have which one? OO double bond, right? Similarly N2, you know very well, have NN triple bond, NN triple bond, right? Clear, bacha? Very, very simple here. If you talk about CO, so if you know this structure, then only you can tell, na? If you know this structure, then only you can tell the bond order. If you don't know structure of CO, then how you can tell the bond order, right? We can tell the bond order using a shortcut also in the MOT theory, right? Otherwise, in most of the questions, we need structures to find the bond order. Like if I talk about the CO2, we are having CO2 here, so we have structure. This is the CO2. So here it have what? Double bond, triple here, double here, single here. In CO2 the even resonance also present. Okay, so I'm taking those examples where students make mistake all the time. Resonance, right? In the morning class, morning class like 11:30 class, you have seen what is the resonance, right? So resonance or conjugation, you can say, is the delocalization of pi electrons, right, in a conjugated system. Mainly you will see whenever pi sigma pi bond is coming, or you can say pi sigma negative charge, pi sigma positive charge, right? Pi sigma radical, pi sigma lone pair. So the delocalization of pi electrons, you can say, is your conjugation or resonance. So that can affect the question of bond order. Okay, you have to take care. So I'm giving one or two questions on that basis, and we'll check about that. So I'm taking the first example here, the most common. I am talking about the carbon ion, right? CO3 2 negative. And now they're asking the question, bache. They're asking the question, find the bond order between the carbon and oxygen. They're asking, in the carbonate ion, please find the bond order between carbon and oxygen. Fine, bache. Okay, you're asking, sir, in H2. Okay, if H2 you are coming, bacha. If I give you H2O, you can see in H2 you're asking the structure is which one? This is structure OH, right? So if they ask what is the bond order between oxygen and hydrogen, so what is it? 1, right? Between oxygen and hydrogen, how many bonds are there? 1 bond is present. Fine? Yes, 1 is present, right? Very easy to give answer. Issue comes in these when resonance come into existence, right? We are having carbonate ion, CO3 2 negative. If you make the structure, we have done it yesterday. This is the carbonate ion. Carbon here, oxygen here, and oxygen, right? 2 oxygen are negative charge, you can see CO3 2 negative. So this will make double bond and this will make single bond. We have discussed this yesterday. Clear, bacha? Now, if you ask, sir, what is the bond order between the carbon and oxygen, right? It looks like here though it is having double bond, but here having single bond. So what is the right answer? So we have to go through some different concept here. We have to see this is having resonance or not. Look at this. This is having which bond? Pi sigma negative. Here also what we have? Pi sigma negative. So here resonance is present. Or I will say simply, the pi bond will delocalize. If pi bond will delocalize, it will not stay at one location. It will go through in all the locations, right? You will see here what will happen. Carbon, oxygen here, oxygen here, oxygen bacha here, right? So one single bond, sigma bond to like here na, one was sigma, sigma, sigma. One is pi. This pi bond is delocalizing. This pi bond will go or will be present in all 3 locations, right? So here this pi will delocalize and give a partial double bond character in all the bonds, right? Even if you see the charge, total how much charge? -1, total how much charge? -2 charge, right? Total -2 charge will delocalize in between the how many oxygen? 3 beta. So -2 by 3. I will say here partial charge -2 by 3 here. Here also how much? -2 by 3. So if I want to find the bond order between the carbon and the oxygen, bache, so what we have to do? Look, bacha, one bond is present between carbon and oxygen, right? Permanent bond. A single bond to permanent present. 1, right? And one pi bond is delocalized between 3 locations. So that one pi bond will be divided between 3 locations. So the pi bond contribution will come only how much? 1 by 3. I'm saying once again, sigma bond, sigma here, sigma here, sigma here is permanent. And pi bond contribution, how much coming only? 1 by 3rd, right? So from here if you solve, what's coming beta? 4 by 3 I will say. And 4 by 3 means how much? 1.33. Yes, bacha? It's not beta 1.5, it is 1.33. You will say 1.33. Because one pi bond is delocalized or distributed in between three locations, right? You imagine that I am having four chocolates. I am having four chocolates, right? And I am having three here. I am having three kids in my class, right? So if I give one chocolate to every kid, so one, three gone. Now one left with me. So the one chocolate left with me, I will divide in three parts. Na? So every kid will get how much? 4 by 3, 4 by 3, 4 by 3. No issue, bache, it's okay. We can make mistake, okay? But we have to learn from the mistakes, fine? So I have 4 chocolates and I am dividing in 3 kids. So 4 by 3. Directly also you can say, sir, total how many? Total 4 bonds and how many locations? 4 by 3. Directly you can also answer. How you can go through like this one? Imagine. Here, total how many bonds? 4 bonds, 1, 2, 3, 4. And 4 bonds will divide in how many locations? 3 locations. 1 here, 1 here, 1 here. So 4 by 3. That is 1.33. Fine, bacha. Right? Okay. Done? Let us see the next one, bacha. Okay, I'm giving some more examples. Look at this. Try this one, bacha. We are having here, imagine we are taking here ClO4 minus. Can you try this one? ClO4 minus. I am giving structure. Definitely you can think about these bond parameters, so you can say bond order when you know the structure, right? I am giving structure. It is ClO4 minus. So think carefully. What is the bond order between the chlorine and oxygen atom? Think about it. Fast. Yes, better. Great. Right answer, right answer. Good. So here we can see Cl and O, which we can check here. Directly we can go. Total how many bonds? 2, 2, 2 and 1. Total 7 bonds. 7 bonds. And how many locations, beta? 1, 2, 3, 4. So 4 locations, we can say 7 by 4. Right? 7 by 4. Very good, right? Okay, you are saying 1.75 is coming. Okay, fine, good. Otherwise, if you think again, here we have pi bond, pi sigma negative, pi sigma negative, pi sigma negative, right? We are having conjugation here. So pi bonds will delocalize in between every location. So sigma bonds are permanent. Sigma here, sigma here, sigma, these are permanent, right? And pi bond will delocalize. Pi bonds are delocalizing here. And total how many pi bonds are there? 3 pi bonds. So if you go this way, you can say one bond is permanent between every chlorine and oxygen. And now 3 pi bonds are delocalized between the 4 locations. So I will say 1 plus 3 by 4, right? Same thing. 7 by how much? 7 by 4. Okay. Same thing. One more, beta. One more you can try this way. Example I am saying, it's phosphate ion, PO4 3 negative. We are having PO4 3 negative. So please, phosphate. Very easy. It's phosphate, right? But think about it. Make the structure and think about it. So what is coming in phosphate ion? So in the phosphate beta ion, if you see PO4 3 negative, definitely it's O negative, it's O negative, it's O negative. So these will have single bond, and this one oxygen have which one? Have double bond, right? Simply you can go as you did in the last question. Total how many bonds are there? 5 bonds. 5 bonds will be distributed in how many locations? 4 locations, right? What's coming? 1.25. It's coming 1.25. Clear, bache? Easy. In the other way, you say there is sigma, sigma, sigma. Everywhere one sigma bond present, and one pi bond will delocalize in 4 locations. So how much coming? 1 plus 1 by 4. Same thing is coming. How much? Pi by 4. And yes, beta, if we talk about the partial charge also, if I say per oxygen how much charge is present? Total how much charge? -3 charge. So -3 charge will delocalize in how many oxygens? 4 oxygen, right? So I will say it's -3 charge in how many locations? 4 oxygen, right? So -3 by 4. Right? In this case, in the above case, beta, if I talk about here, so here how much partial charge you can say on per oxygen? If I check, so how much charge? -1 charge was there, and how many oxygen? 4 oxygen, so -1 by 4. This way you can find the partial charge per oxygen also, right? So it's very easy. Clear, bacha? Good, good. Next, the next one is now you know about the bond order, right? So beta, remember one thing. If bond order will be high between two atoms, so definitely the bond length become small, small, small. If bond order will become higher, then the bond length becomes small, small and small, right? So remember, higher the bond order, this will cause bond length shorter. Right, clear? So if I ask a simple question here, compare. Question is compare bond length. So definitely bond length questions also depends on the structure. If you know the structure, you can tell the bond length sequence very easily. So bond length, compare the bond length between carbon and oxygen. So I'm taking the examples, bache. Imagine one of the example is I'm taking CO2 here. One example is CO and one example is CO3, 2 minus. Right? I'm calling it A, I'm calling it B, I'm calling it C. So which one have, like, give me increasing order of bond length. I want to ask the increasing order of bond length means smaller bond length. Which one is there, A or B or C? Then next, right? Tell me, bacha. Fast. What's coming? It's better. Okay, right one. Very good. CC single C. Okay, here I am discussing about only bond between the C and O. CC there is no bond. I think by mistake you did here. Look at this one. CO2. If I talk about the CO2, bacha, CO2. This is C here, double bond O here, double bond O here, double bond O, right? So it is having here double bond. Carbon, oxygen have which bond? Double bond. So bond order here how much? 2. Okay? Yes. The bond order between carbon and oxygen how much is there? 2. Okay? Actually CO2 have resonance also. If you even make its resonating structure, you will find the average bond order between carbon oxygen will come how much? 2 will come. Okay? Why it is having resonance? If you say it have lone pair sigma pi. So if you will make its resonating structures and then you find by the concept, then also 2 will come. I'm not going in detail, okay, because resonance is not our main topic this time. And next one, if you talk about CO, Here we have CO. Here you can see beta CO, the bond order between carbon oxygen, how much is 3 here, right? The next case, if we see, it was a carbonate ion, and we know very well. Just now we have seen this concept. In carbonate ion, the bond order between carbon oxygen was coming 1.33. It was coming 1.33, right? Now we can see, bacha, but the question is about the bond length. So something having large bond order or higher bond order will have lesser what? Lesser bond length. So definitely B will have the smallest bond length because higher the bond order. Then which one? B, A, and then which one? C. It's BAC. Yes, with the right answer. You gave right answer only. Very good. Great. You gave the right answer. Fine, bacha. Good. Okay, fine. Now let us see one more question on this basis. I hope we are clear. Okay. Same, but the same question I am giving again. Okay, before this question, let us see one small point. Okay, this is the bond order. Okay, we are discussing about the bond order. So we have one shortcut also. We discussed about the bond order, so let us discuss one shortcut also of the bond order. If you will do this shortcut in the MOT theory, okay, and mainly it is applicable to the homoatomic molecules, but sometimes a little bit applicable to hetero also, mainly for diatomic molecules. So if you see, bacha, here we have electrons and here we have the bond order. Electrons in the molecule and here we have the bond order, right? So here you have 8, 9, 10, 11, 12, 13, 14, 15, 16 here, 17, 18, 19, 20, right? These are the number of electrons in the given molecule. These are number of electrons in the given molecule, right? And remember, you remember this one. If your molecule have 14 electrons, beta, its bond order will become how much? 3. Right? And if you go, is beta, if 14 are the number of total electrons in your molecule, then the bond order is 3. If you increase electron by 111, the bond order will decrease by 0.5, right? If you see, if you go back side, 13 electrons, bond order how much? 2.5. 12 beta, bond order how much? 2.0. 11 how much? 1.5. 10 electrons beta, what is bond order? 1.0. 9 electrons means how much? 0.5 bond order, and 8 means how much? 0 bond order. Clear, bacha? Similarly, if you go in this case, 15 electrons, again bond order decreased by 0.5. 2.5 here, here how much? 2.0, here how much? 1.5, here how much you can say? 1.0, here how much? 0.5, and here we have how much? 0.0, or you can say just 0, right? So this you can use. This you can use to find the bond order in mainly homoatomic molecules, but sometime you can apply on like CO you can apply, right? Cn negative you can apply, okay? But this will not be applicable for CO positive. It's exception case. We will discuss in the MOT theory in detail, right? But many of the question you can solve using this technique, right? Like if I'm asking, like example I'm saying, please tell me. Here I'm writing the molecule. This is a molecule. Oh, and here tell me the bond order, beta. Let us see one of the example. I'm saying imagine N2 I'm taking, right? It's N2. Here I'm saying N2 plus. Imagine here I'm saying with a F2, and here I'm saying O2, and here I'm saying it's O2, 2 negative imagine, right? And here I'm saying Be2. Okay, so please tell me the bond order using all of these. Use this trick and tell me the bond order here, right? Fast, fast. Yes, beta. Then tell me what's coming. You can answer all the question in single sequence. Just you can put the answer in same message with comma only. Okay. Yes, beta. Very easy. You see the N2 beta, N2 have how many? N2 have 14 electrons, so very easy to give a bond order. How much? 3. N2 plus beta have how many? 13 electrons, so what is the bond order? 2.5. F2 beta, F2 have how many? 9 and 9, 18 electrons, so how much beta? Bond order 1. O2 have 16 electrons, so bond order how much? 2. You can see now here. O2 2 negative have beta how many electrons? 18 electrons. So bond order how much? 1. Be2 have 4 and 4 8 electrons. So beta 8 electrons means how much? 0. Right? 0 bond order. Okay? And this year they asked one of the question. What was the question exactly? Okay, I will tell you here. I will tell you the next point. So this is the way you can easily get your bond order for some of the easy molecules. Fine, bacha? So please, now asking, compare the bond length. Same question. Compare the bond length among given molecules or ions, whatever it is. So imagine that I am having O2 here. This is your O2 plus and this is your O2 minus. Imagine this is it. So in this they are asking compare the bond length, right? So you can find first bond order and you know the bond length order will be reverse of bond order, right? So first of all try to answer or try to make the bond order sequence, right? And then using that easily you can answer the bond length also. Right, bacha? What's coming? Very easy, bache. If you see here, its bond order 16 electrons, bond order 2. How many? 15 electron beta, bond order how much? 2.5. 17 electron, how much beta? Bond order 1.5. Right? It is a bond order. So bond order sequence, if I write here, sequence wise O2 negative have the least bond order. Then which one? Then O2 and then which one? O2 plus. Bond length, if you go just reverse way, bond length beta, O2 plus has the minimum, O2 and then which one? O2 negative. Okay, very easy. Good, right answer beta. Right answer. So now what question they asked in the NEET exam this year? Very easy question that they asked. Definitely if number of bonds are increasing between two atoms, if number of bonds are increasing between the two atoms, definitely the stability will increase, na? If two atoms have more bonds, like two atoms have single bond or double bond or triple bond, if bond order is more, means they are making more bonds with each other, so that molecule will be more stable. So I can say higher the bond order, so higher the bond order, so higher the stability. Simple question from MOT, simple point I am saying. Okay, not from just MOT, you can think very clearly that higher the bond order, so higher the what? Stability. On this basis they asked a question. They asked statement type of question. What they said? They said if bond order is 0 in between two atoms, then the molecule will be very stable. Very wrong, right? How? You can see, bacha, here I said Be2. Here I am saying the Be2 have the bond order how much? 0. That means two beryllium atoms will not even make a bond between each other. So how this molecule can be stable? Similarly, if you go, beta, if I find the bond order between He2, bond order comes 0. If you find the bond order between Be2, just now I said it is 0. Similarly, if you go the bond order between the Ne2, how much come? 0. So if two atoms are not making a bond between them, so definitely that molecule can't exist. That's why though He2, Be2, Ne2, they don't exist. And if bond order is 0, it is highly unstable, or I will say these don't even exist. So higher the bond order, higher the stability. Lower the bond order, lesser the stability. It was very easy question from your NCERT in the NEET exam. Right, bacha? Clear? So this point you know very well. Clear? So I am asking you one question on this basis of bond order and stability. Right? Try to give the answer. Okay, bacha? Okay, so what do we have here? Compare. Compare the stability. Right, here I am saying beta, one thing is N2, okay, one thing is N2 plus, N2 2 plus, right? These are the three, you can say, molecule or molecular ion. Think about their stability. Again, stability also depends on what? Bond order. So check the bond order using shortcut, and then you can answer about the, which one? You can answer about the stability, right? Okay, Vijay. So we know very well, if you look beta, it have how many? 14 electrons. It have 14 electrons. So bond order should come how much? 3. N2 plus have how many? 13 electrons. It have how many? It have 13 electrons. So bond order how much? 2.5, right? It have 12 electrons. So the bond order should be how much? 2.0. Here bond order must be 2.0. Fine, bache? Clear? So very easy. The bond order sequence is very, very clear. The bond order sequence coming N2 2 plus, then N2 plus, and then N2. Fine. If you go for the stability, so you can give the stability sequence very easily. Reverse, sorry, direct way same way beta. N2 2 plus, N2 as well as what? N2, right? Higher the bond order, higher the stability. Very good answer, right answer. Okay, bacha? Okay, good. So now one small point more. Actually, hybridization is very detailed topic, definitely, but I am just relating it with the structure. If you know the structure of molecule, then easily you can find the hybridization. How? Definitely there are various methods to find the hybridization, but on the base of structure, if you have structure, then how you can find the hybridization? That is also our application, right? So one small shortcut I am writing only, and not going in detail. Just application. Using structure, how you can find the hybridization of the given atom. So hybridization beta, how you can find? It is first just find the sum. You have to find the sum of sigma bonds. Remember, no pi bond, number of sigma bonds plus number of lone pairs. So you have to see the structure, and in the structure the given atom is making how many sigma bonds, and it is having how many lone pairs, right? Count this sum. This sum, if this sum is coming 2 beta, if this sum is coming 2, that means your element is sp hybridized. If sum is coming 3, the element is sp2 hybridized. If sum is coming 4, it is sp3 hybridized. If sum is coming how much beta? 5, it can be what? sp3d hybridized. If sum is coming 6, it is sp3d2 hybridized. If it is coming 7, it's sp3d3. Okay, you will see some different type of hybridization also. If you go mainly in coordination compounds, right, you will see beta, there is sp3 and there is dsp2 also once. Here also you will see there is a dsp3, you can say. Here you will see d2 sp3, right? But mainly these comes in coordination compounds, right? In your chemical bonding chapter, normal molecules, you will see these one, simple one. Clear, bache? Fine. So we can take 1 or 2 example. I'm saying you will use this trick when you have structure. You have structure, you made the structure using the previous concepts, and then you want to find the hybridization also. Imagine, right? The very simple example I am taking 1 or 2. Example I am taking, imagine there is water. In water, we have this structure of, right? We have this structure. Imagine I am having ammonia here. This ammonia have this structure here, okay? I'm saying SF6. I'm taking some of the examples. SF6, fine. Okay, bacha. And imagine we are having this one, XCF2. I made the structures, right? Without writing the structure, you can find the hybridization also. That is different technique. Yes, beta, this is the last class, I think. Okay, this is the last class today. Now I hope you will come soon to the offline classes. Okay, so online, I think it started from 23rd or 22nd, I think. So it is last online class today for your bridge course of long term. Now I hope you should join offline classes soon. Okay, we have started our offline classes also. So hope to see you soon in offline classes. Fine, bacha. This is S2O. Okay, this is S2O, bache. No, beta, tomorrow there is no class. Now I think online classes will be over today. Okay, this is the last class for this long-term bridge course. Okay, now you should come in offline classes. Fine, bache. Definitely you will see more details and more concepts in offline classes. These are just basic concepts we discussed up to now, which will help you in your offline classes and the year coming ahead, right, bacha? So in this case, in the water, you see beta, oxygen, I am talking about the oxygen, right? Oxygen making 2 sigma bonds, sigma sigma, and 2 lone pair. Total how many things are there? 4. 4 means beta, it is what hybridized? It is sp3. Very easy. The next one, if you see, in case of this ammonia, nitrogen have 3 sigma bonds here, right? Nitrogen making 3 sigma bonds and having 1 lone pair. Total how many things beta? 4. So 4 means, you know, what is it? sp3. In this case, sulfur is having 6 sigma bonds. You can see 6 sigma bonds plus 0 lone pair. Total thing how many? 6. Beta 6 means, you know very well. What is it? It is sp3d2. Fine, bacha? Clear? Very good. And the next case, if you see, XCF2. In XCF2, xenon is having how many? Xenon is having 2 sigma bonds and 3 lone pair. Total how many things, bacha? 5. So 5 means, you know very well what is coming. It's coming sp3d. Okay? 5 means sp3d. So count sigma bonds plus lone pair. Easily you can give the hybridization. Clear, bacha? Very good. Okay, when I am taking last example. Imagine I'm taking the example of SO2. I'm saying SO3. SO3. Tell me, bacha. Tell me in the SO3. Give me answer for SO3. If I have structure of SO3, can I find the hybridization using this formula, using this shortcut? SO3. Yes. In SO3, if you count for sulfur, I am finding for sulfur. Hybridization is not for a molecule. Hybridization is for atom. Like in the SO3, sulfur have what hybridization, right? So I am finding for sulfur here. Out of two bond, always one is sigma, one is pi, sigma, pi, sigma, pi. So here there are 3 sigma and 0 lone pair on sulfur. Total thing how many? 3 beta. And 3 means what? sp2. Okay, bache? Yes, you get the right answer. Fine. I hope you enjoyed the session. So, okay, bache, thank you very much. See you soon. Okay, bye.